Hi guys, and welcome to your final installment of the Chapter 3 Notes, Atoms, the Building Blocks of Matter. Today we will be looking at atoms and their relationship to mass and their relationship to moles. So we will be using our periodic table and a calculator today as we go through these notes. If you have those available, now would be a good time to get them out. So let's begin. So let's first relate the atoms to mass. So we do this through the mole. That is why the mole is so important in chemistry, and we keep talking about it, and you take the mole as a pass to class. The mole, as they shortened it, M-O-L, whip-de-doo, but they shorten it. So I guess we don't get it confused with the animal, the mole, but the mole is shortened to M-O-L. It is a unit. It's our SI unit for the amount of a substance, and it is equal to the amount of substance that contains as many particles as does 12 grams of carbon-12. There's that carbon-12 again. We keep relating everything to carbon-12. Well, you'll notice the mass number of carbon-12 for 12 AMUs. Well, if we relate the number of particles that we would have in 12 grams of it, we're going to get the mole. You'll notice mole is something that we have not used as a unit yet, so it's going to be new to you. Grams is something that is not new to you. Grams is something we use in the lab all the time. So we have to have a relationship between all of them. I don't ask you to go back into the lab and get so many atoms or get me so many moles. We usually relate it to grams. But when we work with it, we may want to know how many moles. That's going to be very important when we start looking at how these elements react with each other. So an important number we're going to look at is Avogadros number. Avogadros number is 6.02 times 10 to the 23rd. Or when you're in the classroom, look above or behind the screen above the blackboard. That big long number, that represents Avogadros number. That is what 6.02 times 10 to the 23rd looks like. And that is the number of particles in 1 mole of a substance. So if we want to know how many particles are in 12 grams of carbon-12, guess what? You have 1 mole, or that many particles. So this is how we're going to start relating our number of atoms to a certain amount of grams. So if we want to know that in the lab, I ask you how many atoms are in the 3 grams that you just weighed of a certain substance, you would be able to look that up or at least calculate it using Avogadros number. This is why it's going to also be very important to know how to do scientific notation on your calculator. When we start now relating things to moles, we get molar mass. So this is going to be the mass of 1 mole of a substance. So again, if we have 12 grams of carbon-12, we have the molar mass. The unit we're going to use instead of just grams is going to be grams per mole, and that's going to be very important that we are using that unit. It is going to be equal to atomic mass. So before we had the atomic mass units based on your relative number of isotopes. So now we are going to look at it being a molar mass. Don't have to do anything else except look up the number. The numbers are going to be the same whether I'm asking you for the atomic mass or I'm asking you for the molar mass. The number is still the same. The only thing that has changed is the unit. Atomic mass would be AMU, molar mass would be grams per mole. Easiest thing to do when we start using them in calculations and we start looking them up on the periodic table is we're always going to round them to the whole number. It's just going to be easier to work with. We don't lose decimals. We don't misplace decimals as commas. So just round everything to the whole number. So of course, if you're looking at the molar mass, it's what is contained in 1 mole of atoms, or 6.02 times 10 to the 23rd atoms. So let's look at doing some gram-mole conversions. So if I gave you moles and I wanted to know how many grams, or I gave you grams and I wanted to know how many moles. It's just really a simple math problem, changing from mass to moles. We just use 2 ratios. What is mass to moles? Well, we know molar mass equals grams over moles. Told you that would be important. So we're going to use that in our conversions from mass to moles. So if we are going from mass to moles, as our top arrow shows, mass is in grams. We want to get rid of grams and we want to turn it into the unit moles. So to get rid of grams, we want to put it on bottom. We basically want to divide by grams. So we do this nice times a line, and then we write something on top of the line and something below the line. This area is just a ratio. When you put something above and below a line, you're just making a ratio. So we're going to build two ratios to change mass to moles. So the first one, if we're changing from mass to moles and we want to put mass or get rid of grams, we're going to put it on bottom. So we are going to put the molar mass, which is in grams, on the bottom. How do we find this? We look it up. So to find molar masses, we look them up. And where's the best place to look it up? The periodic table that I gave you. On top then is what you want to change to. So this is going to be in moles, and this is always per 1 mole. This 1 is always. If ever we're using mole in the equation and it's with grams, it's always 1 mole. So the only number you have to look up is molar mass. You just need to remember, if we're using moles, we always use 1. So if we are going the other direction, so we're now changing from moles to grams, we want to get rid of moles, and moles would go on bottom, so we would have 1 mole on bottom, and we would still put the molar mass on top. So you can see all we did was flip these ratios. So let's do some problems and take a look at how these ratios work. We are going to look at what is the mass of 3.5 moles of the element copper. So we always look for, first, what's given. And in this case, 3.5 moles is what is given. So we're always going to start there. So we're going to start with 3.5 moles. And we know the element we're using is copper. So the symbol for copper is Cu. You will get used to some of these symbols as we use them more and more. So 3.5 moles of copper. Then we do our times a line. When we times the line, now we're going to use this ratio. Well, we know we want to get rid of moles of copper, so that is going to go to the bottom. We don't carry the number with us, we just carry the unit. So we're going to change or get rid of moles of copper. On top is what we want to change to. So the second thing you need to find is, what are we changing to? And mass is what we're changing to. So we know mass needs to go on top, and the unit for mass is grams. So in front of grams, we put the molar mass. So we're going to need to look up the molar mass of copper. It was 63.54. So rounded up, that would become 64. So we would put in 64 grams. And then since we have mole, remember that number is always 1. So then we just multiply. So you multiply through on top, and you divide by anything on bottom. So this would be 3.5 times 64 divided by 1, and that equals 224. Remember, we canceled out moles, so we're left with grams of copper. So it's always helpful to put in the units instead of just trying to use numbers, because it really helps you guide where you need to go and what you're getting rid of. It's going to be very important coming up in a later chapter to really start writing in those units. Remember, a number means nothing without a unit, so you really need to get in the habit of writing those units. Can't stress it enough. It's going to make things so much easier if you write in your units. Let's do another one. A chemist produced 11.9 grams of aluminum. How many moles of aluminum were produced? The first thing we need to know is what is given. So we have 11.9 grams of aluminum. So that's what's given. So that is where we're going to start our problem. So we have 11.9 grams of aluminum. And next, we times our line. Then we know we want to get rid of grams of aluminum, so that's going to go on bottom. And then we always want to look for what are we trying to find. So we want to know how many moles. So this is what we're changing to. So whatever you're changing to goes on top. So grams of aluminum are going to cancel out. Moles of aluminum are going to stay on top. Now we need some numbers. So in front of moles is always 1. In front of grams, again, is your molar mass that you looked up. So we're going to look up our molar mass for aluminum, and that is 27. Again, rounded to the whole number. Again, you multiply by what's on top, you divide by what's on bottom. So this would look like 11.9 times 1 divided by 27, and we get 0.44 moles of Al. So here's a third example for a gram-mole conversion. Again, we're looking for what are we given? Where are we going to start? So in this case, we are given 5 grams of calcium. So that's where we start with 5 grams of calcium. And we times a line. We know we want to get rid of grams of calcium, so we are going to put it on bottom. And we want to change to moles, because that's what we are looking for. So we know we are going to change to moles of calcium. Grams of calcium will cancel out. And now again, we add our numbers. Always 1 mole. Grams of calcium we look up, which is 40. So again, we look it up. And then we do the math. So again, 5 times 1 divided by 40 will give us 0.125 moles of calcium. Our last example, how many moles of gold are in 3.6 times 10 to the negative 10th grams of gold? Again, this is what we were given, so this is where we're going to start. So we have 3.6 times 10 to the negative 10th grams of gold. And we are going to times a line. Get rid of grams of gold, so we're going to put it on bottom. We want to change to moles, so we put it on top. So we've canceled grams of AU, changing to moles. Moles is always 1, and grams of AU is 197. So do the math. So 3.6 times 10 to the negative 10th divided by 197 gives me 1.83 times 10 to the negative 12th moles of gold. If you are still having problems with these, you'll see some more conversions coming up in just a second. But don't forget to try some of those book problems. I will have answers for your book problems so you can double check your work. This will be a good skill you are going to need to know for upcoming chapters. I'm going to keep saying that because you are going to need to see this again. If you can follow through this, it's going to make chapter 9 and 10 much easier. So now let's use conversions with Avogadros number. So you can see I've set up 2 ratios again. So we're going to go from moles to atoms, molecules, particles, and formula units, which gets long to write, so we just put FU. Ha ha ha, let's laugh now. We are going to go from moles to atoms. Remember, what we want to get rid of goes on bottom. So when we are going this way, we are going to put moles on bottom, and then we're going to put one of these units on top. So we'll just go with atoms since it's easy. Now, in front of atoms, we use Avogadros number. Do you remember what that number was? Better memorize it. Okay, it is 6.02 times 10 to the 23rd atoms. Moles, just like when we're using grams, is always going to be 1, because by definition there are 6.02 times 10 to the 23rd things in 1 mole. You'll notice we do not need to know what the substance is at this point. There's nothing to look up. So we could be looking at any substance we want. As long as we're going from atoms to moles or moles to atoms, we're just using these constant numbers. So if we're going the other way, we just flip over our equation. So 1 mole on top, 6.02 times 10 to the 23rd atoms on bottom. So let's do some equations. First one, how many moles of silver are in 3.01 times 10 to the 23rd atoms of silver? We're going to start it the exact same way. Look at what's given. So this is what's given, so that's where we are going to start. 3.01 times 10 to the 23rd atoms of silver. And we're going to times the line. Then we're going to look for what they're asking for, or what they want us to change to. We want to get rid of atoms. It's going to go on bottom. We want to change to moles of Ag, so that's going to go on top. Always 1 mole, and always 6.02 times 10 to the 23rd atoms. Then the math is exactly the same. We multiply by what's on top, divide by what's on bottom. 3.01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd on bottom. And we get 0.5 moles of Ag. Now be careful when you're working with these. If you don't use your EE button, make sure you put in parentheses. Otherwise, you're going to end up doing this, dividing by this, and then multiplying that answer by this, and we don't want that. So make sure, if you're not going to use that EE button that we tried to teach you in Chapter 2, make sure you are putting parentheses around to get the right answer. Let's do another one. So how many atoms of aluminum are in 2.75 moles of aluminum? Always start with what's given, so moles of aluminum. So we have 2.75 moles of aluminum times a line. We want to get rid of moles of aluminum, so it's going to go on bottom. What we are looking for this time is atoms, so that is going to go on top. 6.02 times 10 to the 23rd always goes with atoms. So 1 always goes with moles. So we do the math and we have 2.75 times 6.02 times 10 to the 23rd. Again, use that EE button or your parentheses. And we get 1.66 times 10 to the 24th atoms. Let's do our third one. How many moles of tin are in 2,500 atoms of tin? So what's given? So what we are going to start with. So 2,500 atoms of tin times the line. We want to get rid of atoms of tin, so it's going to go on bottom. We are changing to moles of tin, so we're going to put moles of tin on top. Atoms cancel, 1 mole on top, 6.02 times 10 to the 23rd on bottom. And we do the math, so 2,500 divided by 6.02 times 10 to the 23rd, and that gives us 4.15 times 10 to the negative 21st moles of tin. Last example, how many atoms of strontium are in 4.6 moles? So that's where we're going to start. 4.6 moles of strontium times a line, getting rid of moles of strontium on bottom, changing to atoms of strontium. So 6.02 times 10 to the 23rd, and 1 mole, canceling out moles, left with atoms. So 6.02 times 10 to the 23rd times 4.6 gives us 2.77 times 10 to the 24th atoms. Now let's work on conversions between Avogadros number and mass. You take a look at the screen and you go, whoa, Miss Santiago, there's a lot of stuff on the screen. That's just too much math. Well, it's really only one thing very similar to what we've been doing. The top portion just kind of shows you how we get to the bottom portion. So the long form up on top, the shortcut below. I'm going to give it to you right away. I'm not going to make you do the long and then show you the shortcut. I'm going to give it to you right away. If we're going from mass to moles, we know that we wanted to get rid of grams. So we put grams on bottom and we put moles on top. We always were in 1 mole. This was molar mass. Then if we were changing from moles to atoms, molecules, particles, or everybody's favorite formula units, we wanted to get rid of moles. Moles would go on bottom, and we would put Avogadros number on top. Well, if we do the math and we do what we were saying before, whatever's on top can get canceled with what's on bottom, so we notice 1 mole is going to cancel with 1 mole. We've already canceled our grams, so that's already been canceled, but moles is also canceled. So why go through all of these steps in order to do this kind of problem? It's important to know that we go through moles because all of them are related to 1 mole, and that's why I show you this. But we can do it just straight mass to moles. So same thing, ratios are still the same. If we want to get rid of grams, we put it on bottom. So again, on top, follow your arrow. So we put molar mass, which is in grams, on bottom. And then we put 6.02 times 10 to the 23rd atoms on top. If we're going the other way, again, getting rid of that, we flip our ratio so that we have 6.02 times 10 to the 23rd atoms on bottom and the molar mass in grams on top. Since we are using molar mass, again, the substance is going to matter. You will need your periodic table out. Let's look at some examples. So what is the mass of 1.20 times 10 to the 8th atoms of copper? This is our given. That's where we're going to start with. So 1.20 times 10 to the 8th atoms of copper. And we're going to times a line, getting rid of atoms of copper on bottom. So we have atoms of copper, adding to that on top what we want to find, which is mass, and mass is in grams, so we want to get to grams of copper. Atoms of copper will cancel, but we need the number. We don't cancel the number. And grams of copper we put on top, which is 64 grams. So we do the math. So we have 1.20 times 10 to the 8th times 64, and we're going to divide that by 6.02 times 10 to the 23rd, and we get 1.28 times 10 to the negative 14 grams of copper. So again, we multiply by what's on top and divide by what's on bottom. Let's do another one. So how many atoms of sulfur are in 4 grams of sulfur? So this is our given. So we're starting with 4 grams of sulfur, and we're going to times our line, looking for atoms. So atoms is going to go on top. We want to get rid of grams of sulfur, so grams of sulfur is going to go on bottom. That's going to be canceled out then. So we look up grams of sulfur. So we have 32 grams of sulfur. 6.02 times 10 to the 23rd atoms of sulfur. So our math would be 4 times 6.02 times 10 to the 23rd divided by 32, and we're going to get 7.53 times 10 to the 22nd atoms of sulfur. Next example. What is the mass of 4.51 times 10 to the 23rd molecules of ruthenium? So our given, 4.51 times 10 to the 23rd molecules of ruthenium times your line. We want to get rid of molecules of ruthenium, so it's going to go on bottom. And we're going to put on top what we are looking for, which is mass. So grams of ruthenium. Molecules cancels, but we need some numbers. So in front of molecules, 6.02 times 10 to the 23rd. In front of grams, we look up ruthenium, and that is 101 grams, and then we do the math. So 4.51 times 10 to the 23rd times 101 divided by 6.02 times 10 to the 23rd, and we are going to get 75.67 grams of ruthenium. Last example. How many molecules are in 738 grams of uranium? So 738 grams of uranium, because that's what we started with, times a line. We want to get rid of it, so it goes on bottom. So grams of uranium. We're changing to molecules, so we're going to put molecules of uranium on top. So 6.02 times 10 to the 23rd molecules of uranium. Grams of uranium, again, remember you look up, it's been a while since I told you, it's the molar mass. So grams of uranium is 238 grams, and that equals 1.87 times 10 to the 24th molecules of uranium. So that is a little introduction to conversions. You're going to be doing a lot more of these coming up. If you have questions, again, please try those homework problems, or those book problems, I should say. Come in, check your work, see if you're on the right track. It's the same process over and over and over. The things you want to remember is that molecules always goes with 6.02 times 10 to the 23rd, or atoms, or formula units, or particles. If you're using grams, you're always looking up the molar mass of the substance. And if you are using moles, you're always using 1. So those are the things to remember when you are doing conversions. You always want to cancel out whatever you start with, which means it goes on bottom. Whatever you are looking for goes on top. Please come with any questions. We want to make sure you can go through this process.